Hello everyone, I'm here to give you an example of how to accomplish and have success with learning target 1.3 and 1.3b. Let's get right into it. So one of the biggest things that you're going to want to do is to read the question carefully. So if we look here, let's read it. Liquid sulfuric acid and solid sodium sulfate are mixed together. So we're just looking at these so far. We just know this is a chemical, this is a chemical. But this says it's a liquid and this says it's a solid. So we mix those two things together to produce gaseous sulfur dioxide, which is smelly, and other liquids and solids. This was done twice, trials below. Given is the data from before and after the reaction was ran. So if they're saying that they ran the reaction and we're looking for sulfur dioxide, remember that's the gaseous thing, we need to look at just that gas that was formed. So if we're looking at before and after, we have to look at the difference between these two. So to do that, we take the difference for trial A. Let's look at that one first. So let's head over here, write down the difference between the two. So the difference for A is going to be 4.55 minus 3.25. So that equals for A, 5 minus 5 is 0, 5 minus 2 is 3, and 4 minus 3 is 1. So 1.30 grams, because it says grams right up here in the mass. For B now, let's look at the difference. Again, 13.66 minus 9.76. That difference is 6 minus 6, 0. 6 minus 7 can't do that. Borrow. Got 16 minus 7 is 9. We had to borrow, so that's 12 minus 9 is 3. 3.90 grams. And remember, this is a gas, number one, so it's not going to have very much mass. And number two, we can't graph, like, if something does not have any volume associated, we can't get our density from that. Density is an actual measurement of something, how much mass something has in a given volume. So we really, if you graph two, these here and these here, that doesn't work because we're really not looking, especially this should be a clue that we have 0 milliliters. That's your clue. So we have 1.30 grams for A and 3.90 grams for B. That's just enough to do our graph on the next page. So the first thing we want to do for our graph, remember we want to get a line that's grams over milliliters, so this over here is going to be mass. And you need to include units of grams. Now down here, we're going to have, which is going to have units of milliliters. Now we need to use our proper scale. We look back. We know we're going to have 3.90 at our top, 1.30 at the bottom, and down at the bottom, we're also going to have 500 and 1500 as the difference. So let's make sure we show that. We can just use 1, 2, 3, and 4 if we want to. That should be just fine. Make sure we include 0. And then, like I said, we can do 500 milliliters displaced, 1,000 milliliters displaced, 1500 milliliters. And we'll just do 2000, so we have an upper point. Over here we can do 5, so we have an upper point. Ideally you use the whole graph, but you don't necessarily need to in this case. And then we want a title, which is going to be mass versus volume for gaseous sulfur dioxide. That's how you know that you're actually looking at what you want to look at. Sulfur dioxide. Okay? And again, our first point, as we noted, was 1.30 grams at 500. And then we had 3.90 grams at 1500 milliliters for both of these. Milliliters for both of these. So go to our first point, 1.30. So 1.30, 500. We make our first point right there. And then 3.90, 1500. So we've got our second point right here. So this is how we make our line. You can make it nice and straight. But really what we're going to use is these 2 points. 1.30, 500, and 3.90, 1500 milliliters. But this is what we were looking for the graph. And again, just to refill that in, just gaseous sulfur dioxide. This is what we wanted. Thank you for bearing with this new board that I have. So, now we need to solve for the equation of the line. So, we know we're going to want y equals mx plus b. Now, if we look up, we see that our b, I'll put the point was right here, and the point was right here, and this was our line. So, again, 1.30, 500, 3.90, 1500. But our b, if you come right down through, the y-intercept was 0. So this is going to be 0. Don't have to worry about it. But we need to figure out what this is. That's our m. So m equals the slope, which is y2 minus y1 over x2 minus x1. So that, in this case, because mass is on the y-axis, is mass 2 minus mass 1 all over volume on our x-axis, 2 minus volume 1, which again equals, we had mass 2, 3.90 grams, minus mass 1, 1.30 grams. Remember, these came from the differences, not actually out of the table, because you needed to say, after it reacted, the gas was produced, and we're just looking at that gas. And then the volume, again, 500 ml, or sorry, 1500 ml, keep it consistent, minus 500 ml, which gives us 3.90 minus 1.30 is 2.60 grams all over 1500 ml minus 500 ml, 1000 milliliters, which equals, in a nice decimal format, 0.0026 grams per milliliter. And this makes sense because remember, water has a density of 1 gram per milliliter, and we would expect a gas to be much less dense than water. So that means our equation of a line is y equals 0.0026x plus 0. Or you could just have y equals 0.0026x. And also, we have just shown, remember, for all samples, we should get this volume, or this quantity, as our density, not volume. It takes into account volume. But this quantity is our density. That's what we need to know. And that was 1.3 and 1.3b. Let me know if you have any questions.